Hello, I'm Samuel Archibald, student founder of Sun, and today we're doing another video for the workshop, and we're actually doing a video on these little RF chips that we're going to be using with the Arduinos. So the idea here is that we take these, we put a header on the shield that I'll give a close-up in a second, and so you connect this to the shield, whichever shield, the motor shield, or the one right here, or the joystick shield that we've given you. So the idea is that you connect it to those, and then you go ahead and you put those on the Arduino. So they you connect to the SPI pins here with the Arduino. So today we're going to show you just how we're going to use the ping and the server Arduino examples. We're just going to show how to use these and the basics of using them, and how to how these two can communicate, and do just a general overview of them and introduction. So these things are really small, and they're based off the nRF something. There's a whole bunch of numbers after that, but it's a really cheap and versatile little chip, and it's very good for the price. And I think the range on these is like 0.1 miles. You can get ones that actually have the full-size antenna on them that go up to a mile, and so these things are really cheap. They're really easy, and let's go switch over to the computer and see what these things can do. Well, before we switch over to the computer, I want to show you the module itself. It's really small. It's got 8 pins on the back. You got the labeling on the back and the symbol for wireless. And this is made by Seed Studio, or most of these are anyway. And it's just, let's see how close we can get this in zoom. Focus rather. There you go. So you see it has the antenna, the crystal, the chip, the header, just a couple of filtering capacitors and some LEDs. And it's just really simple. This is nothing, and that's why it just costs a couple of bucks, $2.50, I think it is on Seed Studio. But yeah, so this is what we're gonna go ahead and look at, and this is what the shield should look like when you're done with it. So it should just have a whole bunch of wires coming from the SPI and power and ground. It should go over to this header. I didn't solder this. If I soldered it, it would have been really neat. But the idea is that you just go ahead and you just plug it right on there. You plug this. You plug this right into the shield. You just plug the shield right into the Arduino. And then the theory is that you get both the transmitter, rather transceiver, this is a transceiver, and the shield at the same, you get those both at the same time. And one thing to note with these things is this is a transceiver, so it goes both ways, but there's still a master and a slave, sort of. So like the master can send whatever it wants to the slave, but the slave can only send return packets back. So it can only say stuff in response to the other one. At least that's how I've been told that it works. So even though it seems like they're both talking to each other evenly, there's still like a master and slave thing going on. And so yeah, that's that. And let's switch over to the computer now. The camera's dying, so we may not get any real life footage, but there's nothing to see here. I mean, we're gonna have 2 Arduinos. It's gonna look like, get another one. The setup is just gonna look like this. Setup is just gonna look like that. And what we're going to do, as far as to make it so they both connect to the same computer, so you don't need to use 2 computers to monitor these, is we're going to have one be the server and one be the client, and we're going to monitor the serial port on just the client, and then just connect through USB to the server just for power. So you don't need 2 computers, and because you can't open 2 serial ports at a time using the Arduino IDE. So we can't monitor them both at the same time. So what we're doing is we're powering one, and the other one we're powering and seeing the data from. Alright, so let's go do that. Alright, now we switch to the computer. We're going to go ahead to File, Examples, MRF, Ping Client, then File, Examples, MRF, Ping Server. If you don't, you have to install the MRF library, and if you don't know how to install a library, I'll put the link of the video of how to install libraries and getting the IDE set up in the video description, and I'll set up the download link for the MRF library in the description. So I'm just going to go ahead and delete these notes, because to me they're just taking up space. Sorry for any background noise.
include SPI.h, so that makes it so the Arduino has the SPI script available to it. Include nRF.h, makes it so you can hook up a transceiver. Include nRF 24L01.h. That's the that communicates with nRF.h and tells you which it gives it the protocols and all that for this particular transceiver. The chip on this module is the nRF 24L01. And then include nRF hardware SPI driver.h. This communicates with SPI.h. So the two work together to make it so this chip can communicate with the Arduino. Void setup serial.begin at the baud rate of 9600. nRF.SPI, nRF hardware SPI. So that basically puts the nRF hardware SPI driver and SPI, and that combines them. It makes it so they can work together. That configures it, like it says right there. To start setting it up, set the address to serve1. So that's the receive address. So if you have an email, you have a send and you have a receive pin, or send or receive file. This is the send to. This is the receive. So if anyone says I want to send something to serve1, this will go to serve1. nRF.payload size of unsigned long, so it doesn't really, just leave that open. Or just leave that blank unless you have a specific specific length of data that you're trying to send. This is just sending gibberish to both Arduinos. nRF.config, so that makes it so all this stuff that we just configured now makes it so the chip can now work by itself. Serial.print line listening, so that's pretty obvious. Just print the serial port listening. Void loop in the main program. Set a spot in RAM for the payload. So make it so there's a spot in RAM. So whenever the Arduino receives something, it'll go and just put it straight into RAM. And then if the client is sending and this particular program is ready, say that I received the packet. Grab the data that I just received, put it into that data RAM the data RAM slot that I just talked about. Set the send address to client 1. Send that same data that we just put into RAM. So the same exact gibberish that the client put into the RAM of this, it'll send back. Then serial.println reply send, and then go back up to the top and start the entire thing over again. This is pretty close to the same. And oh yeah, one thing we have to do actually is go and configure the receiving address. Where is it? All right, here it is. You have to go ahead and take this out. Then get rid of that. You have to have nRF.channel is equivalent to then whatever channel you want to listen to. Copy that and just paste it in here. There you go. So now we have the channel. And if you need to edit the pins, so if you get these pins incorrect, you can actually get rid of these two. So if you accidentally wire the CE or CSN pins wrong, you can actually just go ahead and you can go like, oh yeah, I accidentally made this pin 2 or pin 1 or pin 9. It wouldn't be able to use pin 0 or 1 in this particular example because of the serial. But this is all the same. Print beginning. Set the unsigned long amount of time in milliseconds to whatever is random. nRF.set the sending address to serve1. So this is the receiving. This is the sending. Send random bytes in the time to here. Start the time. And then while nRF.sending, serial print line finish sending. So when it's sending, sending, and then if it's ready to receive, or while it's ready to receive, if the message isn't read back in a second, print timeout response from server, and then return back to the top. If that's not true, then go back down here and grab the data that I just received, print the ping. So this is get data, byte and time. So print ping and then print whatever the milliseconds that it sent is subtracted by the time. So that gives you how long it took between send and receive to get the message. So I'm going to go ahead. I'm going to put on the Arduino. I'm going to upload. I have one Arduino collected, so I have the ping server connected. Oops, I didn't want to compile. I just wanted to upload. Well, it'll be faster to upload. If you hit compile, then upload, it'll actually be faster to upload. Just like that. Okay, so now we go ahead and we unplug the server. We plug in the Arduino that we want to be the client. We go over to the client and we send it over. Because I'm using Linux, I don't have to go to tools, serial port, and then select it every single time. But when you have two connected, you do have to. So now, if I plug in the server, I can go ahead and I can open up the serial monitor for the client, and this is what you're getting. Pings. There you go. My pings are pretty high. I think my chip is all messed up. But this is what you should see, and you should see this happening forever. Alright. So that's what you should see on the client side. Now we're going to have to go over to the server side. Alright, so now if I go ahead and go to Tools, Serial Port, select that, and go ahead and hit Upload. And I just stopped the video so I could switch over my cords, because one of them's just for power, one of them's just for data. So I'm going to go ahead and serial monitor, listening, got packet reply sent, and it'll just keep on saying that over and over again. So that is that. So those are both of these examples. I'm going to just give a clip on the how to wire everything up. That's how the code works. Is how to edit it, and that's what it should look like when you are done through the serial monitor.
Alright, so this is the shield, and we'll finish shield, and so unplug this. So on the back you have all the connections that you need to make, and if we, let's see if we can show you those. There you go. So you can see all the connections they're supposed to make, and match them up with the connections here that I talk about. So ground, GND, should be going to GND on the shield. VCC should be going to plus 5 volts, or plus 3.3. Sorry, plus 3.3. And then, let's see here. Ground. And then CE, so the green wire, should be going to pin 8. Or that's the CE. SCK should be going to the brown wire, which goes to pin, looks like 13. Yep, pin 13. IRQ should be going to pin 12. Ground, go to the ground. But VCC, 3.3 volts. And then CE should be going to pin 7. White one, SCK, should be going to pin 11. And then MISO should be going to pin 2. So that's just the basics. Just match that all up, and I'll try to get a reference file. I'll try to put a file in Google Plus with instructions about how to do that. If I do that, I'll put a link in the video description below. And oh, sorry, this wasn't centered. I'm sorry, but that's how that works. That's how the connections are made. I'll put instructions at the bottom. So thank you guys for watching, and see you in the next video. I'll just put this here so you can see what it's supposed to look like. There we go. If you want to make it neater, you definitely can. Alright guys, see you in the next one. Bye.